Hello everyone, and welcome back. We are live. Let's get the visual out of the way here. Blip. Welcome back for some more C3. Can you guys hear me all right? Do let me know in the chat if there are any issues. Is the voice all right? Is the music all right? Does anything need to be changed? Maybe I'll lower the music just a tad. Something like that. Hello, Mine Bill. Glad to have you with us. Someone knows C3 in the chat at least. Can backseat drive a little bit when I'm going off the cliff. Righty-o. So, last time we did some Odin, and we did some C3, and the reason I'm doing this is that I'm trying to figure out and see how much work it is to make Traction Point, the game that I'm building, at least a little bit moddable using different languages. Mostly for fun, but there's also sort of like a publicity stunt thingy sort of in the back of my mind that I could do with this. But mostly for fun, and because I feel it is interesting to see how these different modern languages compare against each other. Last time we did a little bit of Odin. I had done almost everything that we actually looked at, but we played around with this a little bit. Let's get rid of all of that stuff. Yeah, we have a very sort of very basic sort of Odin framework going here, where you can create a test component. You can create a game object component with a name. You can register that. You can hook up some functions, and then you can print some stuff from those functions. And then, of course, you can add that to one of the game objects, and you can actually see these things being printed here. I was thinking we would try to do the same in C3. We're not quite there yet, but shouldn't be super long before we can do this. And then I figured we would actually do something kind of interesting. Right, we have a question. I have a question about how you do bindings. Do you manually write the C interface to the C++ code, or is that automatically generated? Excellent question. It's actually something I'm gonna get into. Well, we can do that right now. I'm gonna sip a little bit of coffee here. And then we can look at that, because that is actually what I had to do last time. Let's see. Can I actually run anything on this machine now? If I try to run the game, let's run it here from. Yeah. Okay. Excellent. So this is where we kind of left it last time. For those of you who watched until the very end of last stream, this is where I wanted to go. I wanted to get to these bind functions. So what's happening here is that the game is, first of all, it believes it's loading a Zig DLL, because that's kind of what it was originally made for. That is, of course, not the case. We're loading a C3 DLL here. But what it is complaining is that it can't find a function called bind core. So there are a whole bunch of these binding functions that we need to actually hook up here. And we looked at the DLL last time, and we had a whole bunch of these guys. The reason I need to bind all of these, or I need to make all of these functions exported. I need to export them all from the DLL that we are building, is that the game engine, when it loads a mod DLL or the game DLL itself, for that matter, it wants to find a whole bunch of things. And so the minimum set of these functions that it wants to find and call is quite large. This is about half of them. The thing that's actually missing from this is all of those bind functions. And it's complaining here that it can't find the first bind core. So we can't actually run this now. The way I do that, the way I handle those bind functions, is using, yes, it is like the short answer is that it is generated, yes. And so I have a small little binding helper called bind-a-lot. And you feed bind-a-lot, sort of a kind of weird mix between C and C++ perhaps. You can see here that we have something called core. I'm going to make that a bit larger for you. At the very beginning. Hey Marcus, welcome back. It's been a while. Welcome back. So yeah, we have something called core here. And this class instruction here or specifier, this is not a C++ class or anything like that. That's like a custom syntax. Later I've been thinking that I should perhaps have called this something like group or whatever, because what we're really doing here is we're just bundling together a bunch of functions that we want to actually group together somehow under the name core, but they're called classes, so whatever. Each of these classes, when we run the binding generator, it creates a binding function. So there will be a bind core, there will be a bind app, there will be a bind mod controller, and so on. Custom IDL, yes. Custom IDL. Actually use a few custom IDLs. The secret sauce here for this is that it's actually not completely... It's not a completely custom IDL. You can see that each of these lines here are actually fully valid C. Right? Not C++, but C. And so the idea here is that if you write one of these guys, what you will need to implement on the C++ side is exactly this. You take these function prototypes and then you implement them somehow. And so this guy generates a whole bunch of things. It generates like the class bindings, so we can see here class core, and then it just generates type defs for all of those function pointers. Then we have class app, and so on. And this is actually pretty long. It's like 440. Sorry, 4,400. 4,400 lines of type defs just to bind the sort of the core engine. We haven't really even gotten to like all the middleware and everything that we can bind as well. The implementations are manual, yeah, yes, they are. And so if we go to, what should we go to? Let's go to Sig interop. We do like Merlin, for example. Merlin is which is actually not part of what we've done here, but Merlin has a very similar, if we go to Merlin here in the actual game project, we have a Merlin bind-a-lot file as well. Looks like this. Much shorter, you can see it, compared to the core engine. We have class Merlin manager, has a function load effect, effect description, and effect instance. So this is for playing particle effects. And we can see that we have those things here. We have there's the Merlin manager load effect. Here's the effect descriptions, and then the effect instances. And typically it just works by like you reinterpret casting something to an effect instance and then doing the actual thing. So this is the part that I write manually. And you can see that if we want to bind them to WASM, to WebAssembly, we sometimes have to like wrap functions in some special functions because the calling convention there is different. Once this weird execution environment thing. Evidently this WASM binding thing here is not actually done. But yeah, I think sig interop, basis sig interop, this is probably the big one. Yeah, here's where we bind all of the native types, and then we bind all of the WASM types, aka WAMR types. WAMR stands for WebAssembly Micro Runtime. And so we have like this, if we go back to the core one, we want to show an assert dialog here, right? We have an interrupt string message, an interrupt string caption, and returns an integer. We can go here and we can find this somewhere. Show assert dialog. Bloops. And here we go. We call down into our own show assert dialog file. Function. And then this thing is just given to the bind core function. Look at that. We have the bind core function. This is the exact thing that the engine can't find now in our C3 code, right? I was wondering if it was completely automated, so you only ever write the C++ code, but I guess it's simpler to keep it manual if you don't constantly change the API. To be honest, it's not very tricky even if I do change the API. The reason I want to do it, the reason I want to generate it, besides just like the convenience of it all, is to make it type safe. So we can see basis C API, basis SIG bindings, and generated class bindings. This is the same file we looked at in that other Visual Studio Code window. That's essentially like SIG's view into this, but here we have the actual C++. You can see that all of these type defs, these are for the function pointers, and they all have strongly typed parameters like this. And so the idea is that when you get the pointers out of the DLLs, it's kind of easy to make one small mistake when you change, you change a parameter there in the API, and you remember to change it on the Zig side, but you don't remember to change it on the C++ side, something like that. So I'm generating these type defs here, basis Zig core show assert dialog CB, but I also generate the Zig equivalent of that. So here we can see, here is the same thing. And we can see here that this is also using strongly typed parameters for everything. U8, 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 U64, I32, interrupt string. And you have just like a whole bunch of these guys. Whole bunch, all 918 of them. And just regenerating this stuff is like a 1 second thing. So it is very tricky to actually make a mistake where you now forget to change the API on one side but not the other. I mean, yes, if you change the API and then just don't recompile the DLL, then yeah, it will be broken. That's why I'm versioning these things these days, so that they do sort of a handshake and figure out, hey, am I actually compatible with the game or the engine or whatever. But that's the idea. That is the idea. And with all of these, what I've done since last time is I went and added support for C3 to my generator. So here we can see we have the same thing here. Core, here's the same show assert dialog. CB stands for callback. We have interrupt messages here. Heap allocations. We get a length, or we give it a length, we give it an alignment, and returns a char pointer. Freeing is just giving it the pointer back, and it returns nothing. Like this. And then we generate, again, this should be about 918 lines. Yes, it is. With some empty lines at the end. Of C3 aliases, right? Because C3 wants you to use function pointers through aliases. So this is the stuff we couldn't do last time, and that's why it's complaining about the bind core. Well, here we have the core bindings. These guys, on their own, of course, don't do anything. These are just aliases, so we need to store them somewhere. And here's where we store them. In global data, global variables. And I'm sure this could be somehow perhaps made into like read-only, so you can't change them after they're initially set or whatever. But currently they're just done like this. So we have something called function pointer underscore, and then we have the thing that's called class there in the bind.lot file, but could essentially be called group, and then we actually have the function name, like so. And then finally we have the actual binding function. So here we have bind core. This is the thing that was missing from last time, right? And the thing that is complaining that I can't find that. I can't do anything with this. So what it does is it gets this function pointer from the C++ side, receives it here, and stores it in the function pointer. So after this, we can actually use this just by going to like function pointer underscore core and just calling this guy, and then we'll be showing actually an assert dialog. That's kind of what we did in the last stream with Odin, when we made up like a bogus assert dialog thing. And I'm actually using this already. I'm using this print on host. So if we look at this, you can see, here we go. This is something I created last night. So this is a macro. Not sure if this is like the best way to do it, but this is a way that works. So it's a classical printf function with variable arguments, and we have this va splat for just like essentially taking whatever we gave it here and putting it in here. Wrap that in interrupt string because that's what the API expects, and then we call this function pointer thingy that we just looked at. And this now sort of bypasses all of the standard outputs, so you can route this exactly where you want in the game engine. Currently it just goes to the nope, that's not what I wanted to do. Yeah, shut you down. It just goes here essentially, along with all the other debug output. But it could go like into the actual game window or whatever. So could I get out as a sig function bind core? Well, let us actually build this thing. See if it builds. Hey Sugrado, welcome back. Right, so dynamic library created. So this builds. I wasn't sure actually of that because I didn't write this on this machine. So it could have failed, but here we can see, yep, DLL has changed. Let's move it, copy it into here. And I'm gonna actually, I think I'm gonna want to, let's see if we can make this work. Should be able to just build directly into this folder, right? Let's copy that. And how do we actually make it build into here? Here's a project JSON. Output build. Output location relative to project file. I'm assuming you can also give it an absolute path. Let's hope you can. So I'm gonna comment that out and just do output equals and all of that, and then we probably need to like double backslash these guys. So that's my this is not where you would be putting your mods. You would putting your mods under the traction point folder. This is called the trampoline now because that's my launcher name for this thing. Let's see if we can build it directly into that now. So we should have some files appearing here. Yeah, so now we can build directly here. That's nice. That's nice and neat. So let's see. Can we run this? Look at that. Look at that. Mod manager. C3 mod is loaded. C3 mod. It is loaded from the mods folder. We can maybe get the put down the master volume there. Yeah, so it's loaded from the mods folder. The versions are compatible. It is a native unsandboxed mod. It's enabled and it's loaded. And the description is C3 test mod. Cool. It doesn't do anything yet. That's the next thing, right? Next thing to actually make happen. What was the thing I was thinking of doing here now? Oh, yeah. Right, so now that we can get into this thing and we can see that it actually even loads the mod here, we should see a text in the output about, let's see, native mod 1 component, native mod no zig components. So Odin mod would have loaded the test component thingy that we created and added. I think we actually probably still have that actually in use. Let's go have a look here on the game object types. So we would like to go to the blueprint and dynamic props. So it's this thing, and here we see it, Odin test component. So it's added to one of these small crates. Here we go. This guy now has an Odin test component added to it. Let's remove that guy. Bye bye. And when we have the C3 equivalent, I'm gonna put that there instead, and that should be good. Yeah, we can shut down the preview there to unlock the DLLs for us. But oh, I'm probably blocking that. Yeah, sorry. Yeah, I tried to write here, but I had actually like highlighted things, so it blocks the entire thread. That's kind of stupid. We can disable the Odin mod for now, so that we don't have that. Yeah, it just says restart to unload, because mods are only ever loaded and unloaded at startup. I can't resize these things. Yeah. Anyway, that would be that. The reason we can get into that now is, of course, because now we have those bind functions there. So if we go to that folder and have a look, it is not that one, it is here. Maybe I can actually just collapse some of these together, like so. So let's go here, C drive, and then go to that one. And then we run the same dump in exports C3 mod DLL. Now you can see that, okay. We have the same thing we had before. We have the component factory stuff, flow state, mod controller, propagated values, blah blah blah. But then we have just like a whole bunch of bind functions here. These are the generated ones. We don't really use almost anything from here. We only use one single thing from bind core, which is the print on host thing. But we already have access to like so many things, you know, meshes, messages, physics, player controllers, renderers, scene node, blah blah blah, all kinds of things. So we should actually be able to do just like a whole bunch of things now from the C3 mod without having to like really do anything more on the sort of like handshake side. So that's kind of neat. But before we can do anything interesting on the game side, we're gonna have to do some framework programming still here. So I actually already created a test component. It looks like this. Has almost nothing. That's just an integer because I figured it should have some kind of member there. And we want to register this as a as a game object component, right? So we can actually oh no, not that. Let's close that. So we can add it here, and we can just go, you know, C3.test component or whatever, and then add it here. And for that we need to register it. And I actually already have a call here. Yeah, I have some testing code here that's commented out. Hello world from C3. Can take that away. Here's the Zig version of this, where we essentially give it like a list of component types. I don't do that currently. I just give the component here as a generic parameter. But this is kind of how I'm assuming that we're gonna register these guys. So there's gonna be, you know, other components after this, like that. So let's keep that here and take that away. And so what happens actually here is that this guy gets called when the game engine starts up, and then we call it back with all of the components that we want to register, and we have this callback for that. Oh, 1 second. I'm getting a phone call here. Alrighty then, sorry about that. Right, so what do we want to do here though, in this register component type thing? That is the question. Let's go have a look here on the Odin side. We do basically the same thing. We don't have... yeah, it looks essentially the same. Also have a register component types here. And we have a callback, then we need to call. Then we have this test component register, where it actually kind of like goes in and constructs a list of all of the functions, or procedures, as I should call them here in Odin, that belongs to this component. And then you call init component type. Maybe that should be called actually register component type, I don't know. But anyway, we want to do something similar to what we do here, but on the C3 side. So we create a factory, component factory, which is templated on, or generic, on the type of component that we want to actually create. And then we want to make a component factory interface to that, so that we can give something to C++, which doesn't really understand these languages at all. It doesn't know C3, it doesn't know Odin, it doesn't know Zig. But it needs to understand that, okay, there is a storage place for these components on the other side of the DLL. And that something can be, you know, can be called to create a new component for this game object. And that's why we have this interface, which here in Odin is constructed here with just a bunch of function pointers. Now in C3 we actually have interface support, so I'm gonna attempt to use that for the thing there. But that should be it. That should be essentially all we need. So we need to create a factory for it. We need to hook that factory up so that C++, when it receives a command to create a new component, for example, or update the components, all of the components for the factory, all of that stuff, you can just do it through this. So that's cool. I'm gonna move this Odin code to the side. Of course, we also have the same thing here in the Zig land. Where is Zig land? Zig land is here. And the same thing here. We go to the main file here. Register component types. Here we register just like a whole bunch of types. Again, this is a list, component types, and it even puts some lists together. But you can see that like just the main game list is pretty long. We have a whole bunch of components here that we want to actually register to be usable. But essentially it does the same thing. If we go into init component types, apparently it's actually called init here. That's weird, but whatever. Init component type. Again, we create a new factory. Actually, what we do here in Zig, because this is a comp time thing, is that first of all we create a factory type. You can see that this const factory is actually of type. And then with that type, we actually create an actual factory. And then we figure out, okay, does this component have like an update method? Does it have a pre-tick method? Does it have a tick? Does it have exposed properties, blueprint properties? Does it need exporting? Like, are we exporting a level and this component wants to write some arbitrary binary data to the level? Is it scripted? Does it actually draw itself in the editor? Is that editor state? Then we do a little bit of int pointer casting magic here, because again, like we're crossing the language boundaries here, so we can't just give C++ a Zig pointer and go, hey, here it is, call this guy. So instead I'm casting it to an integer and just storing it there in C++ in integer form, so it can pass it back and we can cast it back. The game, of course, supports, or the Zig SDK supports building as WASM, so that's a slightly different, but this is the path that just registers the native type here. So that should be pretty good. So we need to do all of this in C3, and some of this stuff should be easier to do in C3 than in these other languages, because C3 is slightly more object-oriented than those other ones. I'm not going to go ahead and just outright say that it's an object-oriented language, but it has some more object-oriented features than either SIG or Odin has. So that should help us a little bit. Right. So what's the first step? I guess it would be, oh, I keep doing that. Come on, I don't wanna launch you. The first step would be to look at what I actually already did here. So in the components, I do create the component factory. It doesn't really do a whole lot yet. See, the component factory has the actual like interface for what the component needs to do. They just don't do anything yet. They're all to do. So we need to be able to, well, deinitialize the component factory when the thing is brought down. But we need to be able to create a new component, delete a component, update all components, pre-tick all components, tick all components. You can see some of these things have like on client true or false, because we have separate lists for the client components and the server components in like a network fashion. Then these are methods that get called on the actual components. So create gets called when the component is created. On object is called when all of the components for the objects have been created. And then draw editor if it actually wants to draw itself. There are more, but I've kept it to this minimal set here to begin with. But here we actually have interfaces. That's nice. And then the component factory itself, it has lists of client components and server components, and these are just I just made them as pointers now, so we have an extra layer of indirection here. But that just makes it so that because the component pointers need to be stable, and ideally we'd like to create them in chunks so that we don't have to do like a whole bunch of pointer indirections. I can do that later. It doesn't actually change the interface of this thing at all. It's an implementation detail. But if we have a list like this and it actually has the pointers to the components, then we can like add and remove to that list, and all of the pointers stay stable. So that's a benefit of that. What else? What does the Odin component actually have? Component factory. It probably has lists as well, right? That's a factory interface. Yeah, so component factory. It's also a generic on a type, although they call it parametric polymorphism in Odin. You can see that it's pretty much the same thing. We have a dynamic list or array of client components and a similar one for the server components. And this is just the Odin pointer syntax here. Then we have a function list. This is something that we probably don't need to actually have separately in C3, because it's kind of like built into the interface. But we do need this interface member thing here. So we do need to store that. And here we can see that we do create the factory. This is all well and good. And I did some testing here, so let's get rid of these guys. We need to get an interface to this factory, because if you create two different component types, register two different component types, they each get their own factory. You can see that as it is generic on the component type, those will also be different types for the two different components, two different component types, and two different component factory types. So to be able to actually use all of those factories in the same way from C++, I use an interface for that they need to implement, and it looks like this. And this is going to be the same interface for all the factories, regardless of what their actual component type looks like. I hope that makes sense. So this is the syntax that we use. We have the actual struct name here. Then we have, which is component factory. Then we have component factory, which is the interface. And then we have the component type, which is the generic parameter here, right? Let's go back. Right, so we create that, and then we get an interface to it. But now we need to store this interface somehow, because we are going to need to do a little bit of hackery and magic here. So this line here just gets the pointer. Actually, that's not what we want. That's what we want, right? That should also build, I'm hoping. Yes. So we get the interface. And then we get the address of the interface, so we shouldn't need that there. I was a bit confused why that would actually even be needed, but it's not. We get the pointer of the interface, and then out of that we can get an int pointer, factory interface int pointer. I know this is a little confusing, even to myself. But I assure you, we're pretty close to getting some like cool things happening here. I think we can actually get rid of that line and just do that. I think that should build as well. Yes. Excellent. So now we get the factory interface from the factory, and then we get the pointer to that. But of course, we can't get a pointer to this because this lives on the stack. So that would just give us garbage memory when we go out of scope. So let's put that into a member inside of the factory interface. That's probably a keyword, isn't it? Interface. I don't know, but I'm gonna call it iFace. And so what I think we can do here, which is gonna look kind of strange, but I think we can do factory dot iFace is factory, like so. And then we can get the address of that, and that is not living on the stack. Let's not cut it, let's copy it instead. I think this should still build. Yeah, and this is strange. That is like, what is that? You're assigning factory to sort of itself. I think we should write a comment here. Store the, or rather like initialize the factory interface with the pointer to the factory itself, something like that. Because it's such a strange line to have there. Right? And now with that in place, we have actually most of the stuff that we need to happen here. We do need to do a few more things. We need to set up the component flags, and then we need to let's see, what do we have? Right, yeah, there's one thing that I'm forgetting here that we need to do. So in Zig, if we go and have a look, we actually have a global factory interface pointers, like fixed array. Create to support up to 200 factories on C++ sites. Let's do the same here. I think we should do something similar here. We should, however, just have the interfaces, I think. Because when the game shuts down, the mod DLL gets a call, which is like, okay, you can delete all of your factories now, because these factories are created on the heap. And if we then have a list of all of the interfaces to those factories, we can quite simply just loop through them and call deinitialize on them, which is exactly what we do here in this public function deinit component types. This is an old style Zig loop. Nowadays you can do it much more elegantly. You can just do it for like this. We can take that away. Right? What? Oh, there we go. We're missing a curly brace there. There we go. Yeah. So we need to do something similar here, right? In C3. Whenever we call this thing, just loop over the entire array and call deinit. Well, not the entire array, but like until we actually have reached the count. That seems like a good idea. That's a function we have in components. So let's add that to our C3 version of this components. So fn void deinit component types, like so. And now we need an array of those interfaces. Let's get that comment and use it here as well. So maybe just add them here. And let's see if I can remember how this works now. We have I component factory 200 G, what do we call it? Factory interface pointers, 2 G's, and then we have a count as well. That's a U size. What would the appropriate type be here? I don't exactly know. I think we can have it as a uint. Let's initialize that to 0. Something like this, right? And then I bet we can just do like a normal classical C or C++ style for loop, right? There may be some more elegant way of doing this, but I don't want to use heap memory for this. I want it to outlive any of the allocators, at least for now. It should be less than G factory interface count plus I. And now we need to do something kind of interesting, I guess, because we're going to be using the interface. I haven't really used any interfaces, well, kind of ever in Zig. And I think in some of these cases we want to do this calling dynamic methods. So we want to see if the interface has the thing. Well, in this case, all of the component factories should actually have all of the methods. So maybe we don't need to do that. We can just do this I and call the init on it. And that should be good. So this deinit component types you can actually call here from. Look at this. That shouldn't work. Nope. But if we do this, it should work. Right? Yes, that works. So you can see some of these things kind of like start falling into place here. We don't have an app. This is a mod SDK, so this is where we could create our mod controller, which we might be doing later, but not right now. This is where we would destroy the mod controller, and then we would deinitialize all of the component types. Here's some memory allocator leak detection stuff. I'm just going to take that away, like so. You can leave those app things there as sort of like examples for how to do that stuff. But yeah, that would be that. So then, now that we have this factory interface pointers here, we of course need to add that to add the interface to the list. probably done here somewhere. On the SIG side, yeah. Just push it there to that. But maybe we'll try to do these things in the same order. So we've done this essentially. We don't really need to create a type here, but we've done that in C3. The next thing is to create interrupt string types, which we can pass to C++. The interrupt string is, like I mentioned previously, it's sort of like a manual slice, if you will, that works across different languages. There's a pointer and a length. We could also use zero terminated strings here, but I don't do that. I should maybe do it because all three languages, SIG, Odin, and C3 support them, but meh, I don't do it currently. Partly because like all three languages kind of like to work with strings that have a known length. None of them really like natively work with zero terminated strings. It's mostly for C interrupt. So I just use whatever they want to use, essentially, right? We also need this enum that we have up here. Let's copy this guy. I'm gonna have to convert some types into or like adhere to the correct naming conventions here, right? I think it's where did we have that one? Enum. Let's search for enum. Where's enum? I'm just finding all of my own generated stuff here. That can't be that difficult. It's here. Here we go. Here we have some enums. So that's the. This is the syntax enum, and I think I just call it component flags there on the Odin side because it's not really doesn't make sense to have them called SIG anything, and they should just be const uint, or perhaps like inline const uint. I don't know exactly, but yeah. So has update. Oh, update. If we wait a little bit, I think that the LSP should like realize that these are actually okay. And this one isn't. Maybe it's confused by this SIG style function here. Oh, no, it's actually confused by the fact that we don't have a curly brace there. Yeah. I keep removing that because the idiomatic ZIG has it here on the same line, while I think C3 has it on the next one. And it's incidentally, it's also like the way I kind of want to code. I'm just gonna do this. I'm gonna do transform to uppercase, and then we can add these underscores here. Suppose properties, blueprint properties. Of course, most of these things we're not gonna really have, but we do want the elements here anyway. Co-editor as editor state, like so. So that's the component flag. We can do some pretty cool things with macros and like compile type information here to determine some of these flags. But we'll do that in a second. Now, let's go back to the SIG one. Yep, have all of that. We have all of that. Don't have these. We can't really have them in that form. Right, so to interrupt string. Basis string to interrupt string. Well, I'm sort of already doing interrupt strings here in this guy. So if we have a string and want an interrupt string, it just looks like this. So I'm thinking, well, we'll just I'm just gonna make a function for this, I think. So interrupt string to interrupt string, and what we get, what we assign to this is a string. Maybe we can just do return, can we? Does that work? Seems to build at least. Pretty good. We're also going to want to have a from interrupt string, but we don't need that yet. That's for text that we receive from the game engine. So that's one thing. Another thing is that we will want to. Actually, I'm gonna add a new file here. I'm gonna call this string c3, and the module is basis. I'm gonna add the string related stuff to it. All right, we need the imports, don't we? No, maybe not. Nah. LSP was just confused there for a bit. Yeah, the other thing that we need is a string hash. String hash. And we look at the Zig side again, and perhaps even go to the string function here. You can see, here we go. Pubconst string hash is u32. Well, the same thing here is like alias string hash is uint. And we want to, or we need to, I should say, we need to actually have a hash for the seed, which is just set to 0, and this needs to match the seed used on the C++ C# side. Blah blah blah. But we need to implement a function that looks like this: make string hash. And it just so happens that I was speaking to Christopher, the main author of C3, yesterday, and he was kind enough to actually implement Murmur 3.32 for us. It's not actually available in the version that I'm using currently, so I think I'm actually just going to grab that directly from the source code and just plunk it in here, because it's a pretty small thing. And then later on, when we update to a newer version, and I could use nightly, but I'm not going to do that right now. I want an as stable version as possible. How do I get to Discord from here? I bet I can get there from here. And then I just need to go to the right repository. C3C. Not sure this is where the standard library lives, but build utils. That's probably not it. Libstud. Here, that looks like standard library stuff. Hash and murmur.c3. Yeah, you can see that this was added yesterday, so that's kind of nice. And we have the 128 version, not 128 64-bit version, and then the hash 32. And this is the thing that we want here. Yep. Yeah, I'm just looking at this code here. Why is this coloring so confused? But I bet it's because of these somehow. I don't know. GitHub being confused by the colors. So I think this thing actually uses some macros here at the end. Yeah, clearly. So I'm just gonna get, because I only use it in one place, but it is very important in that one place. I'm just gonna get all of this stuff and plonk it into our string thing here. So let's add a major border here for ourselves. This is stuff that I'm gonna throw away later and actually use the official one. Inline version of murmur.c3. Isn't that what it's called? Yeah. From the stdlib. Not yet released. to do. Replace this with the official version when released. Something like that, right? So hash 32, it returns a uint, which is nice because that's what a string hash is. It takes a char data, so this is a slice. Yeah, and the seed is just also a uint. So fn string hash make string hash of this string. And then I need to turn that into a slice somehow. Let's figure out how to do that. But yeah, I think that's basically the next thing we need to do. So how do the slices work? Arrays. Slice. Any C3 gurus in the chat? I think it's just basically like 0 and then ... Yeah, like this. I think that should probably work. Let's try that. So this would be a char slice. Slice is str 0 ... I think that's how it works. And then you can do return hash 32. We give it the slice and we give it the hash seed. Why is this thing confused with me? Missing return statement. Ah, okay. I just added it. Are you happy now? Yeah, that's good. Okay, so we're gonna just keep this in here for now. No biggie. Yeah, I do wonder if this should actually be like a... The from interrupt string should be more of a slice of chars, actually. That's kind of what I'm doing in Zig, actually. So... to interrupt string, from interrupt string. You can see this returns a slice of U8s. That's essentially just that. I think the exact same thing will work here, so we will have an fn char slice from interrupt string interrupt string. I can actually use a pointer there. That's not necessarily like a very good idea, but I think they're all coming through as pointers from the C++ side, so let's just keep it. Keep it there, interrupt, and then, you know, return. Where is our interrupt string definition? I think it is ptr. Yeah, it's ptr. Oh, that's interrupt type pointer. Interrupt string. So it's ptr and len. Yeah. It's literally that. Cool. That should be good. That should be good. Because of course these strings are just like... They are just... essentially type depths for char... for char... slices. I don't know what that inline does there. Can I actually, can I do this? I should be able to pass it directly to, oh, okay, that's cool. That's cool. Right, so this doesn't seem to actually build, at least it's complaining, but I think I can just do a cast here. Yeah, now it at least builds. Right, so you mean this? You mean that should work? Yeah. Okay. Nice. Yes, we have a string. The important thing to remember here is that if you call this with an interrupt string and you get a string out of it, this string that is returned from the function is to be considered a temporary string. You shouldn't hold on to it because its memory lives in C++. So we need to clone it or something if we want to actually like hold on to it for longer. But cool. Okay, that's good. That is excellent. So now we have, I think, basically everything we need to finish this function here. Let's get the zig one here next to. Actually, I can just copy paste this thing a bit. Yeah, let's copy it in here and then we'll convert it kind of like by hand. That away, just for now, and then we'll comment all of this away actually, so that we don't overwhelm the LSP. It's already fighting for its life here. Type name, right? So interrupt string type name. This would be basis to interrupt string factory. Factory.type name. No, that's not how it works here. We're gonna have to probably get that type name from the user, just as manually as we do it here in Odin, because it is not the type name. It's not necessarily the type name, the name of the actual type. Like here we have the name of the type is test component. But the type name is odin.test component because you typically want to actually annotate this somehow. So this is the so-called registration name. Component type name, the context type name. Yeah, we're gonna have to actually have both of those. So let's add them here as parameters. I'm gonna add them, I think, before that thing. String. Come on. Keep hitting the wrong one. There we go. So that would be component type name, like so. Then we have type name hash, and that is of course a string hash. Type name hash is basis make string hash of the very same component type name. Isn't that what it was called? I think it is. LSP is again failing me here. Yeah, it is picking up on the fact that in this other file we're not calling it with the correct things anymore, which I guess is fair enough. We can even do that. We can immediately go like, yes, this is going to be c3.testComponent. And the context type name is something that I will explain to you a little bit later. For now, we're just going to add game object component, the context type name here. Yeah. On the last stream, we were talking about the fact that the LSP here is not very good. I'm starting to feel that now, right? I'm starting to feel it, that like, oh yeah, it's struggling. Or just, I'll try not doing anything in many cases. Which is, you know, we knew that going in. But it's not really helping. Okay. Flags is 0. we're gonna enable some of these flags, not all of them, but some of them. This one actually corresponds to that thing. And then, yeah, G-factory interface pointers. Is exactly that. Factory.interface, I think we're calling it iFace here, right? Aren't we? Yes, factory iFace. No, it's exactly this. There we go. Component index probably isn't found. No, what is component index? It would be like the count. What am I doing here? This is not good. CF pointer count. Yeah, this is just completely wrong. What am I doing here? I know we're writing Odin now, but this is just completely wrong. This is correct. That's fine. But like that? No? How can you even do that? That's just strange. We want to do this, and then we want to do plus equals 1. Is that a thing in Odin actually? Yeah, it looks like it is. It looks like it is. Let's just make sure that this actually builds the correct thing. Yeah, so that doesn't work. That works. Excellent. Okay. Yeah, I've only ever used this with 1. So it did work because we just assigned it directly to that point, to the beginning of that pointer array, but that would have broken with the second component. Whoops, as they say. How was that compiling before? That's kind of what I was thinking as well. It confuses me. I mean, it would have compiled in C, and evidently it did compile in Odin as well. That way it says the value of every element in the array. Whoa, okay. Okay. That is an even bigger oopsie, I guess. So what actually would have happened here then, like here, is that we would have had... Oh, but I was missing that one, right? Okay, I'm just gonna undo this. We can see what I had. This is what I had. So we're setting the same pointer to every single thing, but I'm never setting the count to plus equals 1. So it would have leaked memory here because it wouldn't have actually cleaned that up. Now that I did this, like if I had done this where I actually incremented the counter, but I would have still had this thing, it would actually probably have crashed here because it would have called dinit on something that was already destroyed, right? So, yeah, it's a little... it was a little hairy for a bit. That thing shouldn't compile at all. I don't know, man. I don't know what to tell you. Interface pointers. I think we actually... Didn't we just use... Yeah, we just used interfaces here. So I can just do this. There we go. Interface. Boom. Ginger Bill and his weird decisions. Yeah. Yeah. I should probably do some more Odin at some point. I mean, who has the time for side projects, right? Even though this is technically a side project, I guess. I should do a little bit more of it. But I don't exactly know. It feels like a perfectly fine language, but it's not necessarily like for me. I don't know. Okay. Now, this is where some of the compile time magic comes in. I shouldn't mention his name. He might appear out of nowhere. Yeah, yeah, he tends to do that. I remember at some point, I don't remember exactly what the thing was, but he was lurking in the Zig Discord. And and I was asking for feedback on the game. And Ginger Bill appears and goes like, yeah, it's pretty cool, but it would be cooler if it was written in Odin. and then he left. I was like, yeah. Next game, man. We'll have that. Okay, right. So, has update. What is this? Well, this is a neat little SIG thing where you can just ask, has decal. We give it the type of the component that we are working with here, and we ask it, does the component have an update declaration, which in this case would mean an update member function, method, whatever. And then we do the same thing for pre-tick and tick and draw editor and a whole bunch of other things as well. And then we set the flags based on these values, right? We can't really do this in C3, but we can do something kind of similar, which is something I was experimenting with last night. But now, of course, I don't have it here on this machine, so that's a bit whoopsie. But I think we can actually maybe find it from the C3 Discord if I go and have a look here. Let's see. Yeah, so it should be something like this. It should be like with a $sign if, and then also $defined, and then the type, which comes in here. Oh no, it's actually component type dot update. Isn't that how it actually works? I think it is, and then we have an end if, like so, something like that, something to that extent. And then we can do this, which we can do like flags, uint, and I know I might be able to do some of this. Get rid of some of those cast by using inline there. I'm just gonna try this out now anyway. Component type update. So that would be that. And then we would need to do the same thing for these guys. So pre-tick and tick. That's that. We don't have any exposed properties. I don't need to do that right now. This blueprint properties needs export. Yeah, this isn't even supported on Zig. So that's fun. Scripted draw editor. We can have draw editor. That could be maybe useful, because we kind of already have that function there. Draw editor. You found it, LSP. Good job, good job. I'm actually making my game in Odin. Hey, that's cool. I mean, I'm sure it's a good way. It's a good language for making games, seeing that it comes with all those vendored libraries. I'm sure it's a good language for that stuff. Okay then. So I'm gonna leave these other ones as they are because we don't have support for them anyway yet. That's fine. Then we need something called the libcpp pointer. Get zig libcpp pointer. Here is called just libcpp pointer. So libcpp pointer, and that is literally the. Oh, we are in bases already, so I don't need to call that. Get libcpp pointer. Yeah, there we go. This is literally the pointer to the dynamically loaded library thingy. Because you can have several of them. Of course, every single mod is one. Or it might be a WASM module, but still, they all wrap to the same type there. Oh, Defender. Yeah, whatever. Go away. Go away. So we need to pass that back so that the global function that we are calling actually knows from which library did this thing originate, this call. That's why we need to need to pass it. You don't need to do that with all calls back to the C++ side, but you do need to do it here with this register components call. So do we have everything now then for this stuff? Factory update sorting key. Yeah, that's also something that we don't know at this point, and I think I'm just giving it here. Yeah, update sorting key U32. That has to do with like how early in the frame do you want your component to be updated. The default is 50, so I'm just gonna give it 50 and not really care about that. Type name hash, context type name. This would be update sorting key. And then we don't need to do this casting because we are not doing the whole WASM dance with going back and forth between 32-bit pointers and 64-bit pointers. Factory interface pointer could not be found. Okay. It's called factory iface int pointer. Yeah, that's fine. Okay. There we go. So now, just to make sure we are actually calling it here, and we are. So registering a component, which currently doesn't have anything, with the name test component and the context game object component, base class essentially. Default update order, and we just need to give it the callback. That's pretty cool. Now, one thing I want to immediately test here is if we go to components and we add an else here. How do you add an else? Is it like this maybe? I think it's probably like that. So we can do basis. Oh, actually we can do printf. Component has update. Like so, right? Component does not have update. Because I want to see if this actually works. So now if we build this, is that not supposed to be there maybe? Apparently not. Now we're supposed to see this thing here, right? And then the only thing we should need to do here is to add an update method to this test component, and it should just automatically call that instead. So let's see if that works. Component does not have an update, is what we can see. That looks good. And we can see that, yay, now we are actually loading one so-called SIG component even though it's actually a C3 one. Good, good, okay. This one. So how did you add methods again? Void, no, it's function void test component dot update self float delta time, something like that. And that's not part of an interface. It's just an implied interface essentially. Like this factory business here, they all need to have this dynamic, which I guess is kind of like a virtual function or something. Oh, is it that maybe? What did I do? Component flags. That's what I want. Component flags. There we go. Yeah. Okay, so I'm missing the thing here. That's promising because suddenly I got an error here. So it seems that this thing is actually being compiled now. How cool is that? And that of all things the LSP does pick up, so yes, component has update. Cool. Very cool. This is the sort of automatic kind of feature detection that I have in Zig and that I enjoy. Comment that out. And it still works. But it shows it as not having, yeah, not having an update. So that's neat. Okay. So this thing is actually coming together very slowly, but still. We can take those away. Good. Good, good, good. Okay. Oh, this wrapper thing here is something I was just thinking I might need yesterday, but I didn't end up needing it. So we can take that away. So cool. This is much, much shorter than in Zig. I should add. And of course it doesn't support all of the stuff that Zig does currently, but yeah, this code is much shorter than in Zig. Not bad. Okay, so then we have the factory, and then the factory needs to actually do things. The first one is the D-init. Factories are always created here in this register component type, which I think should follow the same naming convention we call init component type, right? That's just how it should be. Even though it's called register here, all of the other languages use init component type here. So let's just stick with that, or I'm going to be confused later on. Let's go to the game again. Where's the game? Game is here. Yeah, calls init component types, which calls init component type. Cool. So yeah, all of the component factories are always created here in this component type. Here, using the allocator passed in. So as long as this piece of code creates them correctly, that's fine. But we still need to destroy them, and specifically we need to deallocate their memory. So that is why we have a dinit function as part of their interface. If I can find it. Let's go here and call dinit. I'm gonna jump through a bunch of these wrapped things. Here we can see what actually happens. So this is the dinit function for the factory. If we have blueprint properties, BPPs, then we deinitialize all of them here. We don't have that currently, but we need to destroy those lists, client components and server components. I don't know how those lists work yet C3. I'm gonna have to figure all of that out. But then finally we're gonna have to actually release ourselves, which is of course interesting that we do it that way, but yes, we do. So let's copy this here into dinit, get rid of the actual function, comment everything out. So if we use new mem new here, I think the opposite way of that was like, was it destroy? Or what was the thing? Functions that allocate implicit initialization beyond allocating raw memory. Here we go. So the new and alloc functions take a type and allocate just that memory for that value. It's often more convenient than foo malloc. Okay, so it's just free then, I guess. Is it? Yeah, kind of looks like it is. It's just free. Oh, here we have some of those lists. Functions that allocate. Standard library functions that generate... Standard library functions that allocate generally require you to pass an allocator. This allows you to use the standard heap allocator, the temp allocator, or some other allocator you might be using instead. Ah, that's good. It's good to know because we need to do that. List init mem. We're just going to be using the heap allocator for now. If you're using mem, then in general you need to free it in some way. Either this is built into the type, such as in the list example above, or you need to handle it yourself, like in this case. Okay. Mine build says that's because the LSP runs C3C check or something. I'm assuming you're referring to that LSP picking up on those somewhat obscure issues that I was having, and yeah, I bet it's something exactly like that. Okay. Cool. Let's add a function here, which doesn't need to be dynamic, which we can call component factory init, and we're gonna want to have that self there as well. I do like this shorthand for the self. Like this is shorthand for doing like that, right? You can just do address of self. That's neat. Okay, so self dot client components init mem, and then we have server components. Yep, that looks good. And then we can call that here. Maybe we can actually even... We can do all of that here, right? So we can do whoop, factory iFace. We can do self.iFace is self. Like self is a pointer to a component factory. I think that's how it's supposed to be. So then here we can just do factory init, like so. And then here we do the opposite thing. We do free. Is it free? Yes, free. Like so. And then we do free self at the end. Right? That would be that. I think that's how they want us to do it. That builds at least, so that's cool. Okay. Okay. I think if we do this without the address off there, you can only convert pointers to an interface. Yeah, exactly. So that works. That works fine. Cool. So now we do the deinitialization. At this point, all of the components should have been freed when this factory goes down. So we don't need to do any like deleting of individual elements here. And we don't have blueprint properties yet. The blueprint properties are essentially like this. Some of these things can have, like the mesh component here, have like types and meshes and materials and positions and rotations and scales and blah blah blah. Well, these are all blueprint properties. We don't have any of those for the test component, so that's fine. Okay, so now we have covered the lifetime of the factory. We do the initialization correctly, we do the deinitialization correctly, and this until further, notice, until I notice that it doesn't work. But I think this should be good now. So now we can actually turn our attention to these like individual components. So these are all things that are like forwarded to individual components. New component, delete component, update, predict, tick, create on object created, draw editor, and so on. And some of these are actually really, really easy. Update, for example. We can do the same thing we do here. If defined update, we just update all of them. So if on client or else. Maybe we could do that in a more elegant way, but I don't care. Right, how do you do like a for each over everything in a list? Let's see how that works. List. Stud collections any list. I think it's that one. Oh, this is like a reference. Standard library. List push. Do we have any? Don't we have any like? For each is a statement. Yeah, I sort of assume it is, but I would like to see the syntax for that list specifically. For each R. For each element by copy, by reference. Let's see here. For each. Right, so it's item, then colon, and then R, because some languages have like in. Some languages have some like other confusing things. Reverse iterating, that's nice. We have that as well. Right, you can get the index and the item by reference. Well, in this case, the elements are already pointers, so we can just use the item R. Here we have a list. Stir over list stir. For each element list. Hey Christopher, welcome to the stream. Yeah. I essentially just found it. So it's something like this. We have self.client components. Comp. And comp here would then be update delta time. Boom. This is not the most elegant way of doing it with a little bit of repetition, but I can't be bothered by that right now. Just trying to make this work. Okay, that at least builds. And we do have an update, don't we? We do have an update actually. Yay. So let's do basis printf. Test component updating. I need to import it. Port basis, yeah. There we go. Okay, so that's really easy, and that's really nice because this means that we don't have to go through function pointers to do this. Just like we can do in Zig. But I wasn't yet able to do in Odin, and I blame myself for being bad. I'm sure it can be done. But like the parapoly stuff, to figure that out, when you have the parapoly you have the parapoly factory, and then you have also those parametric polymorphic functions that you want to pass in. It was not easy. It's not easy, man. Okay, what do we have? There's no field. Pre-tick. Yeah, okay, that's exactly it, because we're not setting it correctly here. That's tick. Nice. Nice. Okay. Excellent. And we can do the same thing for all of these already at this point. Let's copy that guy. Whoop. Create. Yeah, so here we're not iterating over all the things. Here we are calling it explicitly on a component int pointer. And that's interesting, I think. U-pointer. I think that's a type def for it, or an alias, whatever. It's a U long actually. But yeah, I guess it could be a U pointer, because these are most likely the same unless you're building in WASM32 mode, in which case this would be 32-bit and this would still be 64-bit. Yeah. It's actually supposed to be int pointer 64s. Kind of thinking they should be just int pointers. Where do we have create? Where's create? Yeah, it's supposed to be just int pointers. Meaning essentially U pointers. That guy, yeah. So in WASM32 specifically, all of the pointers that are created inside of that WASM will of course be 32-bit. It is still being hosted inside of a 64-bit application where the address space is 64-bit. That's why I have a dedicated CPP pointer alias, but I also have an int pointer 64 alias. Yeah, these should be just int pointers, and that's probably the case here in Odin as well. I think this is where I took it from. Where's my factory? Here's my factory. Create is somewhere. Where's create? Here's create. Yeah, that's supposed to be just an int pointer. Yeah. Yeah, exactly. I think in Zig it actually doesn't do anything except Yeah, it doesn't use self for anything. The only reason we need this create to go through the factory is that the factory is the one that knows this type, this T here. And I bet we are going to be doing the same thing here in C3. Because we can do like the equivalent of this hasDecl in C3 as well with the macro. Or the, I don't know, conditional compilation, whatever we want to call it. We only need to go through the factory to get this T to know what we are actually what we are casting to. So here we're getting the component int pointer just like we're getting it there. We're casting it to an actual pointer and then we're calling create on it. Let's try to make that happen here. So the type here, of course, is called component type. Comp create. There we go. Look at that. So simple. I don't know if... well, yeah, it does build. It does build. It does build. This is the same for all of these. All of these guys. Except this one has a few more parameters here. We have selected and we have hovered. So you can actually make... kind of like how you can do in Unity, in the Unity game engine. You can just build editor logic directly in game code. So if you have a mod and you created that mod with C3, you can actually make editor logic with C3 just by putting that into a game object component and box that makes it create that component in the editor. It's pretty neat. Okay, that's cool. So then we have what we have left here to actually do. Oh no, I'm doing things out of muscle memory. No C#, please. Terminal, thank you. What we have left to do here now to be able to actually run these components is we have to implement these two guys. Shouldn't be very tricky. And then we have to actually hook up these functions that we can find in the library API that call to the component factory. Here, for example, C factory new component. I think that should also be an int pointer, shouldn't it? Am I just being bad here? Am I just bad at my job? So that's an int pointer 64. However, what is it in the SIG version? Library API. Factory interface pointer is actually an int pointer 64. Huh. What's that? I think that should be an int pointer. Well, I'm not gonna care about that now because it only matters in WASM. Anyway, so factory interface int pointer, we need to do something like this. We need to do I component factory. Right. iFace. Factory interface int pointer. And then now we have a pointer to an interface. I don't know, does a pointer to an interface work with an actual like call? Can we call new component on it? Component. What are the parameters? I don't remember anymore. CPP context pointer and on client. Yeah, should be just those. Then return. It is cranky about something. Let's see what it actually wants. Component factory. Oh. Sorry. It's supposed to be I component factory. Yeah, that at least builds. Cool. Yeah, this is also some WASM business here. I need to just look through that if I decide that I will actually want to have WASM support here as well, because as far as I know, C3 compiles to WASM as well. If I want to make it so that you can actually make WASM mods with this, I need to just go through that and fix up those things. I'm not gonna do that now. That's for future me to solve. Maybe I'll keep that there just as a reference though. Cool, so iFace, delete, component. And what are they just those in the same order? I don't remember. Yeah. Exactly. Exactly. So iFace update on client delta time. Pre-tick on client tick delta time. And this one is almost the same. Oh, that was pre-tick. This is supposed to be just tick. Then we have blueprint properties, more blueprint properties, exposed properties. Don't have any of those. Register angel script, no. Create, yeah. This is important. So iFace dot create, and it's just that one. There we go. Message received, pipe, data received, some avatar stuff. Export, serialize, deserialize. Yeah, that should all be fine. We can do that later if we need to. So, does that build? That builds. Okay, so the only thing we need to do now to actually make this usable is implement these two guys. Then we should be able to like create things in the game. How exciting is that? And the answer is, it's kind of exciting. How do those things actually look here in SIG? I have to jump through the V table here. Here we go. Boom. Right, so I'm gonna copy paste this again and just put it here and comment it out so that we have something to look at, and then delete. It's like the same. And here we're actually running a linear search through that thing and finding the component apparently. All right. Here's some really old Zig again. You don't have to do it this way anymore. You can see this is really old. I could just do it like this these days. Okay, allocate the component on the heap. Well, that should be the same thing as we did here with the factory. So let's just copy that over. But we want just the component type now. Like so. It's component pointer. Yeah. Error defer destroy. Now we're not gonna do that. Here I'm gonna actually, because this is so easy to do here in C3 now, I'm gonna add a piece of conditional compilation here. Which is like, if this component type has an init function, I'm gonna call it ptr init, and that's something that like can be. Should we actually? Yeah, I think we might actually require it to have an init function now that I think about it, because we can pass this CPP context pointer here. This is something that every single component will need to have, and typically it's wrapped in something called the context. But we don't have that yet, and we can leave that there. So we need to store it here, and this is the thing that the component needs to do almost anything when it comes to the object model. I'm just gonna actually require that the component has an init function, because I do that in Zig as well, so it's completely fine. We're gonna take those two guys and assign them there in this init one. So fn void test component init, and then self. Then we need a self parameter, self, like so. And yeah, now it goes away because it realizes that we actually have it. So that's kind of like the constructor, if you will, a little bit. It's a little bit like the constructor, but not quite. On client. If we are on the client, we need to push it to a list. How do we push the lists? We just call push. That's easy. Self client components push component ptr, else we do it on the server. There we go. And here we just cast that to a pointer component ptr. Is that actually, do we have a separate one for the WASM case? New component. No, we don't. Oh, but that's supposed to be an int pointer, not an int64. Yeah, that's why I'm confused. This is supposed to be an int pointer. Yeah. Int pointer 64. In library API. Ah. Okay, this is the magic. This is the magic thing that does it. Yes. Exactly. This is the magic that does it. I'm confused because this guy here returns an int pointer, but the function that actually calls it returns an int pointer 64. But we have this host int pointer from lib thing, which you can see. If we are on WASM, we do like a cast here. Otherwise, it's already the proper type. Yeah. Yeah. Okay. Good. Well, we can keep it as it is in that sense in C3. So new component in here should be an int pointer 64, even though this new component in the interface here actually returns an int pointer, because these are actually aliases. So they should, as far as I know, they should support being just implicitly assigned to one another, as long as the underlying type is the same. Yeah, that's supposed to be int pointer. Good. Yeah. Good, good, good. Okay, excellent. So then we do, what do? We do this thing. We do that thing. When we come in here, we do that thing. We do a component pointer. Maybe we can actually call it the same thing, component ptr. If this thing has a destroy method, at this point is where we actually call that. And if. So component ptr destroy. And that's supposed to be destroy. There we go. Yep, I'm gonna take that away. Then we need to do something similar to this. So this would be on self. No, actually it's not, it's a parameter, yeah. It's a parameter there. So let's figure out how we actually, now I want that reference that we found earlier. So list type. What do we have? How do we remove? Remove at index. Yeah. Remove last, remove first. Remove if. Yeah, that could actually be kind of the one that we are wanting to use here so we can find the thing, but remove. Oh, remove using test. Could do that as well. Anyway, I'm just gonna do remove at, and it takes the index. So we should be able to use one of these lists, one of these fancy for eaches that have the index and the item. So this kind of thing. Except we don't want it in the reverse, we want it in forward, I guess. Index and then item by reference. We don't need that though. Typically call that I, and then this would be just you know, comp ptr, and here we have self client components if comp ptr equals component ptr self client components remove, what was it, remove at, yeah, I break. I've used a swap remove here, which I don't know if it's actually a good idea, but it should be fine. It is like the order is not guaranteed anyway between the, like, individual objects or components, so it should be fine. I don't know if this remove at is actually a swap remove or if it fills the hole, but it shouldn't really matter at this point. Again, we're just trying to make this work now, can make it fancy later. Self-allocated destroy. Okay, well that would just be free. Free component pointer. There we go. Okay, and we are building. How exciting. I don't think we need to do anything else. I think we can actually start creating components now. Adding them to things and printing things. Which is not super exciting, I know. So maybe we'll expose a small piece of the SDK here so we can actually do something sort of visible in the game. Do something game dev like. That would be fun. But I'm gonna take a quick break, quick toilet break. After that, we're gonna launch the game and see if we can actually see some of these outputs that we have here. That should be interesting. So, quick break. I'll be back in about 5 minutes. Alrighty then. We are back. And we should be ready to test this out. Let's build this one more time. And we're gonna need to actually make some notes here about these strings that we pass. I wonder if I should actually make the same kind of registration function that I made here in Odin. So we actually have a test component underscore register, which is then in the same file as the actual component. I think that's actually kind of nice because then you can do like this call here. I think that's nicer. So let's do that. We're gonna have to create one more of these guys. Just put it here. So I'm gonna put it at the top, I think. That's gonna be my standard for these things. And then we just move this call into here. And we call this test component register, for example. Oh, it can't actually be called that. No. But it can be called register test component. That's what it can be called. And then we can call that here instead with just the callback. Like bloop. Right, and then if we have more of them, more components go here. Like so. So then we have the entire components data with these guys still here. I think that's fine. Maybe I can do the same thing I do in Zig, where actually I have those as like fields on the test component itself. So if we go to one of the components here in the game, this one for example, we have the registration name here as an actual field in the means vehicle component, and then you can override the update order and everything here as well. But man, yeah, I don't know. This is maybe quite simply just easier to do it like this. A registration function, then you have the struct, then you have the methods. It's fine. It's fine. Don't worry about it. Okay. This is going to be annoying, but let's keep it as it is for now. It's going to spam like crazy. But it's fine. Let's keep it as it is, just to make sure it actually works. I'm going to add another one. I'm going to add test component create self. That's the only thing we have there. We can do I is, let's do the same thing I did in Odin, or something at least vaguely similar. We initialize this to that number, so we make sure this gets called, and then in here we actually print that. So we do test component create I is %d, and then we do self.I on object created. We can do that. We don't need to print anything here. Bye bye. And then destroy. And we have the updating. We also have the ticks, but yeah, I think we're gonna skip those for now. This should now build. And if for some reason I have like an extra, I've forgotten that, you know, I had an extra parameter here, this should now not build. No. Because now it's like, it's called expected type member int. Did you forget to add it? Well, of course I didn't. I forgot to actually remove it. So this is also kind of neat that it is type safe in that sense. Yeah, we got some errors there inside of the factory C3 file. Okay. Now then, we do need to add this to something. Maybe we'll do the same same box we did previously. So let's copy this name here, c3.testComponent. That is how we can identify this thing. Let's add it to the same one. So I'm going to add a component, c3 test component, and call it c3 test comp. So we give it a type, which is the registration, and then we have a registration name or whatever. And then we actually give it a component name. So you can have multiple components on an object. And they each need to have their own name, a unique name. What it actually complained there about is that, like, it's not a registered component. I sure want to use it. I just clicked yes because we haven't told this editor about it. So we also don't get any URL definition here, but that's fine. We can just go yes. Yes, we have it. We wanna create it on the client or the server. I'm gonna create it just on the client for now, so we get those outputs just once. We don't have any network synchronization on it anyway, so it doesn't really matter. Then we can go here and let's go to one of the simpler levels, maybe. I used depot in the previous one, but it also already has a bunch of those boxes, so maybe let's not go there. And this is the simplest one of them all. It's just a plane. There's a car here somewhere. I might actually not. It's the error that it's complaining about there, so we can just create a vehicle for ourselves here. And now if I create, we should see some outputs here in this top left corner there. If we create one of these dynamic crate number 2s, hey, test component updating, and if we destroy it. So what we have here is test component create, I is 1, 2, 3, 4, 5, 6, and then sometime later, actually in this case immediately after, because like it runs through all of these components that it has, and then when all of them have had their create function or method called for them, then we call the on object created. So in this case it's just like this was the last component to be created. So we got that. Then it's updating. Then we run this destroyed game object. We get one more updating. That is because there's probably like 1 frame delay between the client and the server, and we're now running this on the client, but the command to destroy it comes from the server. And then we actually get the test component destroy. Okay, cool. So that should be pretty nice. It is kind of annoying though that we do this business here, so let's not do that. Actually, we can do bool has reported updating. Can I initialize things here directly in the struct? I don't think I can. No, can't do that. I need to do it like that. And now here I can do if not self has reported updating. Do you want to give me something? Thank you. So it just prints it once to make sure it actually works, and we can do the same with the pre-tick, and this technically is the tick delta time, which is different from the delta time, but whatever. And then tick as well. Pre-ticking and ticking. ticking, pre-ticking. Updating. There we go. What do we have here? Oh, that's probably that, isn't it? Pre-tick. Yeah. Yeah, that was a good error to catch. Let's see. CZ Bozak says, although I haven't used it much, it seems like a really well-designed language. It takes the best features from Rust and C++ and leaves out the complexity of OOP without being too purist. Yeah. Yeah, the not being too purist part I agree with. It seems to not really care about being one of these like big idea languages that can be, which can be kind of annoying to work with because they try to force their way upon you, and for some languages that's completely fine. It's just like, okay, don't use that if you don't want to work that way. Yeah. Zig is kind of like balancing on the edge of being annoying to me. I still really like Zig as a language. But there's some things in there that I kind of grinds my gears a little bit. This is definitely an interesting thing. It really does lower my enjoyment of this, that the LSP is or IntelliSense is as poor as it is currently. That's of course not a knock on the language itself, just on the tooling. But yeah, it's a little annoying. I think we can directly just boot into that level. Probably have a plane and car. Let's have it there. Can run the server on another thread. We're forcing all kinds of things here. Let's not do that. All right. Spawn crate. There we go. Pre-ticking, ticking, and updating. We should get the same thing again. Yep. Of course, we're not getting the draw editor, partly because we don't have a draw editor function, but also because we are not in the editor. So that's the thing. But okay. So far so good. No real surprises really. This kind of just works the way I was hoping and expecting it to. So now if we load into a level that already has a bunch of those, like the depot level. We can see here just a whole bunch of them. Hey. Isn't that cool? Okay, so now would be the time when we would do something a little fun with this thing. So I think the logical next step, if I was just like kind of super determined to use this as a language, would be to put in, to make the context system a little better. Because without the context, the object doesn't really know anything about itself or anything else. Or the component doesn't really know anything about itself. But I don't know exactly how I want to tackle that yet. So I was wondering, maybe we should we maybe expose some of the other APIs here and do something fun with this instead. I don't know exactly. So here we have some of these boxes. If we just destroy them, then we get that stuff again there. Yeah, what do you guys want to see? What do you guys want to see happen from C3, the game? What should we put our time into? Of course, I don't have any math classes or anything ported over. You could just use the interop vectors and whatnot to do math, but that can become a little hairy. But we could do something fun. Why not? Oh, I'm driving on the wall. Yeah. Let's have a think here. What do the APIs actually look like? Okay. One thing we could do maybe. Something that would be kind of a little fun. Something with physics. Because physics is sort of like embedded into the main engine here. We don't need to expose like any other libraries or anything. We need to expose some new types though. Let's see, what do we have? We have physics actor is here. We need to get the physics actor for the object. And then we need to get the physics scene. And I was thinking maybe we could apply a force on it. No, we don't actually. We apply the force here, right? Don't we? Yeah, add force. Add force is what we do. So you know, we could make some of those boxes have some forces on them. That could be kind of interesting. In the same breath, we would also expose this physics actor to the API. Or then we just use these directly. We could use these directly and just like not care. That could also be a fun little thing. Yeah, I think we're actually gonna, because I don't exactly know what I want the SDK, or the API rather. I don't know what I want the API to look like here, so let's just use what we have and do something fun with that. So there is something called a component context. Here we go, component context. This guy, given a component context pointer, this pointer, gives us a whole bunch of different things. For example, we can get the name of the thing. So let's start with that. Let's just print the name of the whatever we have. So if we spawn one of these boxes here, bloomsh, you can see here that, okay, it's called spawn CUGM, like the end of this is randomly generated when we spawn them like this. Spawned MRTK. If we go here to this building and look at these guys, they actually have a proper name. They're called Depot Dynamic Props Dynamic Crate 17 because these guys are actually placed in the level editor. So they have like an actual name and everything. Dynamic Crate 15. Cargo rack 1, and so on. But yeah, let's make sure that we can actually use the context. So in the game object created, I'm gonna make this one step smaller. Do let me know if this is too small for you guys to read. I'll try my best to make it readable. legible. In this onObject created, let's print the name here of this guy using just the function pointers that we have. This is going to be super rough. This is not what the final API will look like. I think the final API will look something like this. Like we will have string name is self.context.getName. That's what it looks like in Zig currently. So like this would be the we want this API at some point. Well, we don't have that yet. So instead what we have is CPP context pointer, which will be wrapped in a context object somehow. But this guy to get the name, we need to do interrupt string is, and then we need to do oh, we can't actually call those directly, can we? Can't call these guys because they're set to be private. I can cheat though and just like make them not private, just for this test. Right, module basis. That should be fine. I think we can call them now. Function pointer, get name. We have a few of those. Component context, get name. Oh. Like this. And then we do basis function pointer, get name. We need to give it the self.cpp context ptr, and we give it the address of is. Something like that. And then we have the string name is basis from interop string is. And then we do name. Name is percentage %s, I guess, and then we give it name. So this is the sort of stuff that we would like wrap underneath this kind of getName function inside of the context object. Eventually. Wants it as a pointer. Okay. So now then, let's go back to that level actually. Now that we're not spamming the output, it's quite possible to actually have it here. So now these things should be printing their names, and what do you know? They are depot dynamic props create 14. What? /c3 test. Oh, right. Okay. Yeah, they're printing their entire name, and their entire name consists of the object name, which is that part, and then there's a slash, and that is the component name. And the component name, of course, is here, C3 test comp. Yeah, so they're printing their entire name. That's fine. And then apparently I forgot a new line. Did I? No? There's the new line. There is the new line. Why is it doing it on the same line then? Actually, kind of looks like it's missing all of that. How long is this? See it down there. It's like 41. I wonder if are we like blowing some sort of limit here or something? I don't know. That's weird. Let's bring that down and create a new one here. Spawn object, dynamic create 2. Yeah, that's the same thing. Test component on object created, name spawned, and then C3 test comp. But then the rest of the string is missing. Like this part is missing. Or actually, this part is missing. Huh. Peculiar. Let's shut the game down. Yeah, you can see it. That's the beginning of the quoted name, but then it just kind of like runs out. I do wonder, are we actually like blowing some sort of memory pool here with this? Let's quickly switch out. Where's the thing that I'm looking for? It's right here, and it is here. Here's a memory pool. Let's comment that out. Actually, let's take that entire thing, comment it out. And do the thing without the memory pool. So this is like, is it A format? For allocating format, I think. Nope. Couldn't define B format or T format. Oh, B format is probably, right? But then B format wants, does it want a buffer? Yeah, it wants a buffer. So it's allocate like, let's see a little bit, I need to cheat here, I don't remember these memory allocation things from off the top of my head. Malak. Okay. Actually, what we can probably do here is just do char buffer 2256 buffer. And then just put that there. There needs to be a slice. Oh yeah, okay. We can take the address of it, and that turns it into a slice. Same as sig actually. It's the same thing here. Same thing again. That's interesting. Interesting. How long is that? That's 85 characters. So it should be fine. Should be able to print that just fine. Oh, can't do that. C3 language. Here, B format. B format, come on. Yeah, so it wants a char buffer, a format, and some arguments. Yeah. Okay, in that case we can put a breakpoint there in the print on host. Print on host is here. 0 terminated. Let's actually make this basis optimize off, right? And I need to run it without that first, or it's gonna just spam it everywhere. Alright, so now let's put a breakpoint there. Let's see what actually comes through from the C3 side. Broop. So here we go. Test component create, yep, that looks good. Okay, test component on object created. Name spawned PMKU C3 test comp 69. Yeah, exactly. So what we get from C3 is sort of truncated for some reason. What am I doing wrong here? Basically, like, take that away. Build that again. I can write here something like this. Does not show. Because it doesn't. We don't see that part. Oh. Oh, I know what that is. I bet I know what that is. I bet we have a... I bet we have a 0 terminate, like a null terminator there. Yeah, you can see we don't see that this does not show text. If we take this away, what about now? Yeah, I will see. This does not show. Interesting. So it's something with this, the string being inserted here that I kind of don't really understand. So is this a string terminated? A 0 terminated string? It might be. But even if it is, this guy does know its own length. Which is, you know, did I build that? I don't think I did. I guess we should even be able to debug this guy because we have the PDB file. Should be able to just step into the C3 code here, as far as I know. Let's see if we can do that. String by default is null terminated. Yeah, but is it if you do this, you print something, and this basis printf goes to B format here, and we could take our temporary format back, but anyway, it goes to B format 256 now, so you should have plenty of space. If you pass it to B format, you have a name, and you format that into a string like this. It shouldn't put a null terminated null terminated character here, right in the middle of the string, if you print it like this, right? I mean, this might be a bug on my part. I mean, it probably is a bug on my part. See, here we can step into the C3 code. Isn't that cool? And see what actually happens. Like IS here, that would be the name of the Oh, right. Okay, yeah, we haven't gotten to the. Here we go. Now we can actually see. Yeah, name is that. It's 24 long. Exactly. Then we come here. Let's add a watch here. 2, 5, 6. I bet there's a 0 terminated character after that name. Oh, we can't do that. We have to do it some other way. We have to do it char and then 200, right? So you can see here, where's that? Component, object, test component on object created, name is, and then spawned, and then C3 test comp, and there we go. There's a null termination character. There's a null termination character, so that is why when we actually come here and we get it out as a 0 terminated character or null terminated character again, that's why this thing actually cuts it off. Or rather, I think it's actually this one that cuts it off. The problem here is that we probably end with a 0 terminated character. What's the length here? 87. So here we go. That's our length. So it's length plus 1, and of course the index of length plus 1 with 87 is 87, not 86, which is the last character. So that's the 0 termination character that we actually want. The problem here is that we have one in the middle of the string. Yeah, you can do string z-str copy to get it as a Z string. The problem is I don't want to. I specifically don't want to have that 0 termination character there. So I'm trying to figure out here, am I actually passing it the wrong thing? Or am I using the wrong function here? Because I don't want it as a 0 terminated character in this case. I want it, yeah, eventually I want it as a 0 terminated character, but the string communication between C++ and C3 should be based on the length and not the 0 termination. So name here is has length 24, and if we cast that to a character pointer and then we print, I don't know, 30 just to get a bit of extra stuff here. Yeah, okay, so that's a 0 terminated character. Interesting. This might not actually be a bug in the C3 layer at all. This might just be a bug in the game engine. Let's see what happens if I do this exact same thing but in Zig, right? So we get the name and then we print the name and we do it on object created, right? Let's get a component that I know we're going to be using. let's do like a gripper arm component should be fine, and we just put it here in onObjectCreated. So we do const name is self context get name like this, right? And you can see it's a const slice of U8, no zero termination or anything. Except it kind of looks like it is zero terminated. Whoopsie, but it shouldn't be. And then we do basis dot print printf actually. Hi, my name is. We can even put it in these things. Can we see this question mark name like that? We're probably actually going to be seeing this twice. Let's just put this inside of this on client case here so that we see it just once, and then we build this guy. Build. Convert to a slice and leave out the null term. Yeah, I don't want to have to do that though. Like, if it's an interrupt string, it's not supposed to be null terminated unless otherwise specified. So I don't want to have to like hack it. I know how I can fix it. I just don't want to have to hack it there. I want it to actually be reported as a normal string, you know. So there should actually be a gripper truck here in this level, which has that component, if I remember correctly. Yeah, here we go. Hello. Hello to you. Actually create, destroy that and create a new one. And we should see this hello text here. We don't though. Oh, do we actually not create that on the client? Yes, we do, because there was some code in there. Or what am I actually building here? Am I building the right thing? I think I am. On object created, on client. Yep, that should be fine. Oh. Yeah, we just see that. I might be building the wrong configuration. That's why it's not visible here. Where's my build zig? It's debug with game release. That should be fine. Yeah, we're building debug currently. Oh, you know what? You know what? I know what the problem is. This is not the correct component. It's called something like gripper truck arm. Here we go. Yeah, the gripper is another object. It's an older one that we don't actually use currently, at least not in this level. What's the properties? We do have on game object or on object created. Here we go. Okay, this is where we want to actually print it. All right. My bad. Oh, and we're running the game still, so we can't actually write to that. Let's shut it down. Bye-bye. Now we should be able to proceed. There we go. Yeah, all right. Can we see this? Yes, we can. Hi, my name is test vehicles gripper truck arm. Can we see this? So it does work. Okay, so it does work when it's coming from Zig. And of course, the important thing to note here is that the function we're calling on the C++ side is exactly the same here, rather the one that gets this, as the one that gets this. But for some reason, the C3 version fails. Now, why would that be? Why would that be? Let's think about this for a little bit. Yeah, this is why it is 0 terminated. And then the length is something. Can I just put a breakpoint here actually? Inside this guy, and then create one of these boxes. Look at that. Debugging works really well, seemingly, with C3 here. So we step into that guy and we go exactly here. Okay, well that time the debugging didn't really work, but that was of course C++, so that was a bit funky. Anyway, let's copy this thing. How long is that? It's 24. It's 23. 23 characters. And we do have the length here as 23. Yeah. Okay. C3 people in the chat. Tell me if I'm crazy here, but I think there's a bug here in this formatting logic, or at least something that's not logical. Because we have this piece of text. Which we can see is 23 characters long. Spawned ESY2/C3 test comp. 23 characters. And it comes through here. I don't think I can. No, I can't make that larger, unfortunately. Hopefully you can see that. And then we have length 23. And that gets stored in the name as well. Oh, but hey, here we have 24. So this guy is now... What? Oh, is that the problem? From interrupt string, of course, doesn't do almost anything. Like it just wraps that in an interrupt string. But length is 24 here. It's 23 there. What? Okay, now I'm even more confused. Let's go have a look here at what this function does. And hopefully someone in the chat can tell me what is going on. So, here's the interrupt string. From interrupt string, it's this guy here. Oh, is this where I need to have a -1? Huh. So this code somehow adds... Can we run with emit IR? I have no idea. Maybe I can. My guess is that I need to have it like that. But isn't that wrong? All right. Like when we're creating a slice here, essentially. The strings are slices. So I can see if it null terms string by default. Actually, I don't think that's a problem here. I think the problem is that look at this. Look at this. We have IS, which stands for interrupt string. Interrupt string is a very simple type, which you can see. I'll put it here on the... Like this, I don't think this has anything to do with actually putting that null termination character there. Here's interrupt string. It's just a char and a length, pointer and a length, right? So we get the interrupt string into is in here, and is has a length of 23. Then I run it through my conversion function here from interrupt string into an like a normal idiomatic C3 string, and I do it like this. So I take the interrupt pointer and then I run it from 0 to the length. And what that gives me, at least according to the debugger here, is a 24 characters long string. Right? That's the problem here. It bumps that by 1. Which makes it effectively a null terminated string. But we don't want that. We want the length to stay the same. So what I'm thinking is, should there be like a 1 here? -1, but that seems really wrong. At least like based on my knowledge of how slices work in Zig. And also kind of based on what I know of how slices work in C3 based on this. Right? Slice length 2. Start 2, slice length 2. Oh, should it be... Ah! Okay. I'm sorry, Embario. That is what you were trying to tell me. That is what you were trying... So you guys want me to do it this way? Yeah, okay, I'm sorry. Yeah. I should have been looking at the chat there. I see. Okay, so it was my bug after all. Just like I suspected. So, from... Yeah, and I can see it here in the documentation now. They're using colon here. So it's possible to use the range where end index is inclusive. Yeah. Yes. Okay, this was the problem. Yes. Okay. I can leave out the 0. Alright, yeah, okay. So basically that. Alright. That's the way we want to have it. So now, if I build this, things should magically work. Hey, look at this. This does not show. I will see the whole thing. Yep. Yep, good. Okay. Okay. Alright, I wasn't crazy, and I also didn't have a very long-term bug in my game engine. It was just me being bad at C3. Okay, excellent. Thanks guys for helping me solve that. That would have been confusing for a while. Cool. Okay, let's do something fun now with that. Actually, one thing at a time. I'm so confused now with everything here. Let's undo that change and rebuild the game. So that we don't get those unnecessary outputs. Cool. Rightio. So now if we do this, take away this stuff. This is what I wanted to initially see. And what Embario was trying to tell me there, but I was being a stubborn jackass, not reading the chat for a bit. Yeah, now we can see. Okay, we have the correct names there. That's good. And if we do this, we spawn a new one. We get some new names in here. Yes. That's all good. That at least means that the context is being routed correctly. We can use the context for things, which is kind of what I wanted to see with this. Let's just comment that out. Cool. I'm gonna take away the update. We don't need the update. We don't need that one either. Or that one. Or that one for that matter. Take away this unnecessary stuff here. I think we'll probably want to create. Or on object created. I don't know exactly. If we want to apply some forces though, we're going to want to create this on both the client and the server. Server is authoritative, otherwise it will correct it back to where it was all the time. So let's do that. You just tick a box here to where you want this guy to actually be living. And then we need to get a hold of this guy's physics actor. And now I'm trying to remember how to get that without having my normal API, but I think there's a function here in the context for getting it. Get physics actor, exactly. So that guy. Let's use that, and we can do it here in the on object created. I'm gonna create a member here for it. And it will be called something like uPointer physics actor. And then this guy will probably be self cpp context ptr. What does that actually look like? You can't go there, can you? It's here. Get physics actor. Here we go. Okay, so it returns an integer. I think that's like whether or not it succeeded or not, because not every one of those have physics actors. But we need to give the pointer where we want the thing stored, and then the actor type as a uint. Yeah, that's fine. Let's look quickly at the Zig one. Get physics actor. We can go to it from here. So here we can see how we are actually calling it from Zig. We have actor cpp pointer, and we have the type, and then it should basically be returning 1. These are some really long lines, so I should really break these up into multi-line calls like this. So yeah, we get the cpp pointer, the actor type. I know for a fact that this now uses a dynamic actor, so we don't really need to check that for anything. And then I'll wrap it in this kind of physics actor ptr struct type, which has all of the nice zigified versions of those functions. We won't be having that. We will be just dealing with straight up cpp pointers here, living on the edge and all of that. That's fine. Let's put that in test component. So we have the physics actor, and we will still need the physics actor type so that we can actually pass it to the thing. So we will give it the address of self.physicsActor and the address of physics actor type. And then this returns 1. I'm just hoping that it'll do it now. We'll figure out if it doesn't. What is it complaining? Globals from other modules must be prefixed with the module name. That's basis for you. Okay. That's good. And then, now that we have the physics actor, we can apply some forces to it. Add force CB. again, we can go see what that looks like. So we give it the CPP pointer, we give it the force, the position, and whether or not we want to wake it up or not. I'm just going to copy all of that. We can do some fun here. So we should typically apply forces and impulses and affect the physics in general in the pre-tick. So let's do it here. So we already have the CPP pointer. We need the force and the position. The force can be just upwards, for example. Sounds like a good idea. So let's create like a basis interop vec3 force 0. I don't know, 500. This may be way too much or way too little. We'll see. See how that works. The position, I think, is just in its local space. Or then it's in world space, I don't remember. Let's have it at 0. It's probably actually in world space, isn't it? Let's see. Physics actor. Dynamic. Rigid body dynamic. Give it in world coordinates. Oh, okay. That's a bit tricky, but we can make it work. We just need to get the world position from the context, but we can do that as well. Component context has get position CB. And I bet this guy, we'll have a look there, and this, yeah, it just gives us the return value as a pointer. Good. So then we need to do, we need to go here, no, there actually. And we can do self CPP context PTR and then address of position. And maybe we can print that position. Printf. Actually, let's not do that because we have so many of those boxes here that unless we don't need to, let's not do it. Cool, and then we have that guy, so that would be basis function pointer physics actor add force and it's self dot physics actor, and the force is address of force, position is address of pos, wake up is true, sure, why not? We can wake it up. It happens to be sleeping. Okay, so now that we run this, all of the boxes should either fly away, or if I have the wrong force there, then not fly away. Let's see what happens. Haha! It's levitating. Hello! Bonk. C3 powered levitation, ladies and gentlemen. I bet there's some levitating boxes here as well, or probably like above this. Yeah, there they are. Hello. They're just chilling out. Oh no, I got stuck. We actually have a script for spawning. I used to have a script here for spawning more of this cargo, but I think I took it out. Okay, well. We can see that we can actually do things already with this. Super clunky at this point. You can actually like make things do stuff with C3 already. And that's why I think it's so handy to do, like, even though we had to do a little bit of like, we had to front load the work a little bit there in the beginning with all of the having to bind all of those functions in the last stream. Now that we have them bound, essentially everything works. We might want some nicer APIs for some of those things. That they hit the roof there, yeah. Bonk. Yeah, it's tricky to drive a vehicle with one of these things now because they're just flying away. Oh no. Okay, let's do something else. Let's do something where it flips that thing on and off. Because now they're just flying away and you can't really do anything about it. So let's make a thing where it counts the time. Float time. And then in the init we do self time is 0. And then we do upwards false. Oh, we can't do that here. That's true. Self upwards false. And then we do here self.time plus equals tick delta time. So this is in seconds. And we can just do if self time is larger than 10, self time is 0. Technically not needed, C3 is 0 in it. Yeah, okay. Yeah, I'm mostly working in languages that don't do that, so. But yeah, you're probably right. We're gonna need to have this init function here to accept the context and all of that anyway, though. So it's good that we have it. Right, so self upwards is that, otherwise it's minus 500. Oh, we don't want that. So it gets like extra gravity all of a sudden, and then it goes back up, something like that, right? See if that works. 10 seconds should, I guess, be enough to actually give it some chance to actually levitate a little bit. Let's go have a look at these guys here. So they're still on the ground. Now they're levitating. Then they should almost be like smashed to the ground because that force is combined with the, yeah, boom. Yep. That's boring though. Let's make it so that self upwards. This really horrible code. I'm just like letting my imagination run wild here. If it is upwards and we're gonna smash it down, then basically what I want here is that actually we don't need to do it that way. We can do it much more elegantly. We do here and we don't have consts here. Float timeout is if upwards, then it's 10. Otherwise, it is let's say 3. Otherwise, they're just gonna be lying there on the ground for a whole long time. Right? So I think that's maybe even a bit too long. Let's do 2. Oh. Rip. Here we go. So just smash to the ground and then they start rising again almost immediately. Switch to this one. Spawn a few boxes here. See, can we actually like? Oh no, that's a big box. We don't want you. We want only the smaller ones. Can we actually drive this now? We need to like be very careful because they keep floating away. Come back. Boom. Boom. Oh, and they each have their own schedule when they get smashed back onto the ground, so it's almost completely impossible. Yeah. Yeah, there's actually a physics blocker here, so you can't actually drive like off the level here. That's why one of those things actually like bounced off the. Well, I think it's probably going over it now. Yeah. There you go. Hello. Went off the grid. Bonk. These guys are just going places. Right, so one thing that I need to solve if I want to turn this into like an actual proper modding SDK is, do you want to make the API object oriented or not? The game engine's API is somewhat object oriented. It is C++, and so that's not really like a problem there, at least from like a style perspective. And I've tried to like replicate that in Zig. So the style is fairly, it's not as object oriented there because Zig is not an object oriented language. But it can be made somewhat object oriented there as well. And the question here is that what should I do about it in C3? If we have like a physics actor in Zig, we have this thing that we looked at already, like oh, that's transform API. We don't want to go there. We want to actually go here to the physics actor pointer. So this is a pointer type as a CPP pointer, which is what we've been working with directly now, and then the physics actor type as well. And then you can give the force like this. So you just go physics actor dot add force, and it has this self pointer here. So it's technically like a method or member function, whatever. Like I don't know if I want to do that in C3 or not, or if I want to have a freestanding function, which is like basically like physics actor add force like this, and just make it a bit nicer with like these proper types and everything. But yeah, maybe it makes sense to have it like this, because C3 is arguably a little more OO friendly than Zig is. Here we have some of those jumping dudes again. Oh, here's someone just going crazy. Hello. Where are you going? Just getting smashed. Boom. Yeah, so that's the reason, because they go high up enough that they don't actually reach the ground or the underlying geometry when they start getting that force again. So they just keep bouncing over the place. Bonk, bonk, bonk. Yeah. Good going. Good going, guys. Couple of them here. Yeah, we have like 3 of them. They're all hanging out behind the shed. Yeah. Sure. This works. This is now basically as far as I had the Odin version, which is kind of neat. And there's some sounds here even. And so I've basically managed to do what I set out to do today. And yeah, like C3 seems like a very, very possible language to use for something like this. Just head bump that box there. I think it looks like an equally good language compared to Zig for this. I'm a little worried about the LSP situation though. Like basically, I don't really need to be worried. I could perhaps contribute to it myself, but of course I'm trying to make this game happen. So I don't really have time for that right now. At least for myself, I think I'd find it a little annoying to use without at least slightly better LSP. It doesn't have to be perfect or anything. But I think it has to be a little bit more easy to use than it currently is. Yeah, this vehicle doesn't have sounds yet. I actually have the sounds already, but they just haven't been implemented. So I don't know. I think the language is actually really nice. Nicer than Sig in some cases. Like it has proper interfaces. It also has operator overloading, which I'm kind of excited to try out when I port over the math classes and all of that. That should be nice. A nice addition. Something we don't have in Zig actually. So that should be cool. Yeah, here we have one more box still doing its thing. What happened to the guy up there on the cliff? It's probably actually that one. I think the other one probably fell off the world. Anyway, I think that's probably as far as we're gonna take this today. Oh, that thing got stuck under the mother vehicle. that's probably as far as we're gonna take this today. This was a fun little side track for my game project. I don't really have time to mess around with C like a whole lot now, but now at least I know that yes, I have a base. Yes, it is working. I would say that this was considerably smoother of a thing than it was with Odin. So that's kind of nice. Let's see. It's annoying you have to configure the C3 LSP to reduce the time it takes to do stuff. Configure the C3 LSP to reduce the time it takes to do stuff. The default is like 2 seconds. Oh, okay. Oh, you mean that there's some sort of like timeout or something that like that it's slow. I've actually seen that it's pretty slow. Yeah, I see that it is highlighting something for me, and it's highlighting something for me, and I see what the problem is, and I go fix it, and then it takes forever for it to actually like recognize that I did the fix. I made the fix. Right? That's actually kind of annoying. Yeah, I agree with you. It should be faster. Like, I can't imagine C3 being so complicated to parse, as someone on the Discord said, that it's just like that would be the reason why there really isn't one currently. I'd have to imagine it's just like a lack of maybe time from the community or whatever, and I fully understand that. That's not a strange concept to me at all. Like, SIG doesn't seem like a particularly difficult thing to parse. Maybe for some of the like macro and compile time stuff, things, those can be kind of tricky, but like nowhere near as complex as something like SIG comp time or Jai for that matter. Like, those things can just like absolutely do somersaults around your code. It's just a config. Okay, let's have a look here. Go to user setting and search C3. Also, it's not actually here in the. This is the wrong thing overall. User settings, you say. C3. So here's the C3 LSP path. Yeah, there doesn't seem to be anything other than this. Yeah. User settings. C3. C3 language server. Diagnostics delay. Okay, here we go. Default 2000 milliseconds. Let's make it 500, so that would be half a second. So now if I do something here, maybe just do that. Save. Yeah, still takes a significant time for it to actually recognize that something happened, as you can see. Or do I need to save it? Is that it? Save. And now it's not even. Yeah, that was significantly longer than 2 seconds. Maybe I need to restart it or something. Okay, so now we have the diagnostics delay there. Sure, I mean, yeah, that doesn't really bother me as long as there is a setting for it, then that's fine. C3 again. There we go. What do we have here? Enables formatting with a Clang format. Okay. Yeah. Okay, yeah. Yeah, I don't mind that. That's fine. Not sure it really did what it said on the can though, but maybe I need to restart language server. Oh, is that a ZLS? Yeah, that's a ZLS specific command there. What is the thing I'm looking for here? I'm looking for the output from the. There we go. C3 LSP. An error. Exit status. Oh, is it crashing all the time? Is that the problem? Here it has done some things. Yeah, well, like I said, I don't really have time. Even if this was like working perfectly, absolutely perfectly, I don't really have time to like port my game to C3 now, and that was never the plan anyway. The plan was just to like see if we can actually do something fun with this, and how well the language itself kind of like seems to fit in a project like this. And yeah, I think it does fit quite all right. Here we have some some boxes flying around the scene. Yeah, those things have probably escaped from that base over there. Some wild boxes in their natural habitat. It's kind of interesting actually that they kind of, I guess the shape of the terrain kind of makes them like come here to the same place. It's like at least 3 of them. There's a few more. Stupid. Stupid. But yeah, anyway, I don't really feel like, you know, necessarily debugging the LSP right now or thinking all that hard about it. I'm hoping it will get better over time. Maybe at some point I'll have more time to actually look into making C3 like an official modding language. That would be kind of nice, because I know not everyone is super excited about Zig as a language. And I think C3 is much more, at least like syntax-wise and overall concept-wise, it's much more traditional. If you're coming from like a C++, C#, like background, maybe even C background. Which is not like it's not me bashing C3. It's like I think it's actually a compliment to the language. So yeah, that might make sense to make an official modding language. But I think I'm gonna sort of like think about this a little bit. Maybe do expose some small features, figure out how to do the context there. Hey, look at those guys just bouncing. They're so happy. Yeah, these cliffs need to be redone completely. These are horrible cliffs in this demo level. There are just massive amounts of boxes here. All of the boxes have escaped from their prison. Let's run a script to open that door over there. Open main gate. Should be some boxes. Yeah, there's some boxes inside of this house here. have trouble getting out. Yeah, they're not even actually touching the ceiling there. Boink. So yeah, that's kind of my plan. I think I'm gonna sort of sit on this for a little while and see what I want to do with it. But this was fun. Fun little sidetrack. Thanks everyone who helped out on the stream today, and thanks everyone who just came to hang out in the stream. But especially big thanks to the C3 people who kindly helped me again with my shenanigans. That was awesome. If you want to play the game, you can already do so today. Just join the Discord. There is a link below, and I also put one in the chat in the beginning of the stream. Join the Discord. On the announcement channel there are instructions for how to get a Steam key so that you can get into the playtest. And you can actually even do modding today of the playtest. You can create your own mods for the playtest. There is a whole wiki page and everything, and links to that you can also find on the Discord server. And you get to play the demo mission. And if you would like to help me out with the game project, you can do so by going to Steam and wishlisting it. That helps it out a lot. And of course you can subscribe to the YouTube channel. My plan for the next month or so is to do just a whole lot of different things. I will be continuing with some of the level design stuff that I've been doing now in January, in an effort to make some new areas for the campaign. That's going to be super nice when we actually get to a place where I can like decorate them and I can actually reveal them to you guys, because I know I haven't shown them off yet. There's also going to be some gameplay programming streams, I'm sure, because I will be adding things like improvements to the conversation system, camera shakes, and all kinds of things that I have planned. So if you want to just hang out and watch some gameplay programming in Zig, look forward to that as well. And who knows, maybe I'll do another C3 or Odin stream at some point. That could be fun as well. For now, though, I thank you for your time today. Have an excellent rest of your weekend, and see you next time.